In this lesson, we're going to take a look at Newton's laws, and we're going to take it nice and easy. So this is definitely a place where the learning curve gets kind of steep for Physics 1. Newton's laws, there are three. We start off with talking about the law of inertia. And then we'll talk about what forces are and how they connect to acceleration. And then finally, the third law, the so-called action-reaction. Starting off with just a force and defining what it is, it's very simple. It's just a push or a pull. And when objects have a force that's acting on them that isn't counteracted by something else, then they experience a change in motion. And there are three ways to change motion: speeding up, slowing down, and changing direction. The strength of the force is something that we can measure. We're used to the term pounds in here in the United States, but the SI unit is called the Newton after Isaac Newton. So in our first law, we really define what inertia is from a conceptual point of view. This is an oft-quoted law. Objects in motion stay in motion. It's what way people commonly think about it. But there's a really important thing about the motion is that it's uniform velocity or constant velocity. And so that means same speed, but also same direction. Because there are three different ways you can change your motion, and they speeding up, slowing down, or changing direction. And all those require some kind of unbalanced force, some kind of force that's not being balanced out by a different force. Like, for instance, if you're just sitting in a chair watching this video, gravity's pulling down on you and the chair is pushing up, so you're not accelerating. Initial reference frames are a little tricky, and we'll probably talk about them more later on. But it simply means a reference frame that's not accelerating. So mass is a measure of inertia, and we use the SI system to measure it in kilograms, but mass is not weight. And we struggle with this all the time because gravity is a constant on the surface of the Earth, and therefore weight is directly proportional to whatever the mass is. So typically when we're trying to find the mass of something, you weigh it on a scale, which is kind of crazy. Weight is simply the force exerted by gravity. And if you went to the moon, where the so-called acceleration due to gravity is 1/6 of what it is here on planet Earth, your mass would not change, but your weight certainly would. And now in this form of Newton's second law, we have force equals mass times acceleration. In terms of units, we've defined 1 Newton as, just like the SI units, kilograms times meters per second squared. And the summation sign in front means that oftentimes our forces are unbalanced. So let's go ahead and take a look at a situation like that. So I'm just going to go to net force. Here's our tug of war. We've got some people here that are getting ready to pull against each other. And let's see, let's make this a little bit. Yeah, okay, so 100 newtons versus 150 newtons. You can see that the sum of forces is 50. So the summation sign in Newton's second law means that we're going to want to take the difference between these two forces if they oppose each other. And if they were in line with each other, then we would say add them. So when I say go in this situation, the 150 newtons wins and it starts accelerating. All right. And the speed started picking up. Now, if we change this up, if we put more people over here, like get this really big guy. Okay, now it's 250 newtons to the right and 150 the other way. So let's go ahead and see. Right, so now the bigger force is pulling to the left and that's the direction they go. Let's see what it looks like. And then of course they're gonna keep on going faster and faster. So let's see what it looks like in a problem solving scenario. So I'm gonna stop sharing and take a look at a scenario here. And we didn't have a value for that boxcar that they were pulling, but let's suppose that we put one in and we have a force this way of 150 newtons. And then we have a force this way of, well, let's see, how about 200 newtons? And it's not a mass, so let's just pick something generic like 5 kilograms. And the textbook writes Newton's second law like this. I write it like this. And let's plug in some numbers. So a force to the left is going to be negative. So when I do F net equals ma, what I want to do is I want to identify all the players. I've got 200 to the left and 150 to the right. So minus 200, whoops, I don't know where the 50 came from. Minus 200 plus 150 equals 5a. So now we'll take the difference between them, and it's okay that the answer is going to be negative because we know that the net force is in that direction. So I'll bring the 200 to the other side of the equation, and I'm solving for the what the electric acceleration is. All right, so this is minus 50 equals 5 times the acceleration. And divide both sides by 5. All right, so there's a worked out example.